So last time we saw design of payment gateway. We discussed about what is a payment gateway. Payment gateway is an intermediary between the customers and merchants. They are in payment gateway takes care of getting the money transferred from the customer's bank account to the merchant's bank account, right? Now, we discussed about UPI. UPI is an amazing example of a payment gateway. Paytm is another example. We discussed about functional and non-functional requirements. Functional requirement is transfer money from customer to bank, customer to merchant, transfer money to other users, and doing bank account queries or whatever are the features of UPI. Right? We also discussed about there is a use case which is mandate use case where you authorize the money. If you are paying bill every month, you can authorize UPI to do the transfers automatically from your bank account. We discussed about various non-functional requirements, like what is high performance, what is the scalability, what is latency. We discussed difference between performance and latency. We discussed difference between performance and scalability. And we also discussed about reliability, difference between reliability and high availability. We also discussed about fault tolerance. And there could be an application which could be available but not reliable. We also discussed about other use cases like other non-functional requirements like security and usability, which is mostly outside the scope of system design because these are domain specific things. Security should be, you should be aware of the challenges, but implementing it requires domain knowledge, which may be requiring, right, is not relevant to everyone as a software engineer. So we did back of envelope calculation also about how many queries per second is required for something to build like Paytm or UPI. Yes. So we came to a conclusion that we need 8,000 write queries per second. Yes. Then many more read queries would be required. We also concluded that we have around data volume of 750 terabyte throughout you will need, right? Or you need 12.5 terabytes of data volume per month. This is the storage which is required for the database, right? So these were the two considerations we came with. It's looking more favorable for NoSQL database because they are fast. They can do more read and write operations. And they can be scalable, flexible, highly available, fault tolerant, right? So all these features are there, right? So now let's discuss about databases. Yes, see here, we are discussing about databases. In this process, you will be covering a lot of concepts which are around deciding which is better, NoSQL or SQL for any particular use case. So maybe I will ask you as an interviewer questions, you have to answer me. Is relational databases horizontally scalable? Anyone? What do you feel? Are relational databases scalable, horizontally scalable? Or is NoSQL databases better horizontally scalable or not?
Sorting partition comes under the horizontal scaling.
Yeah. Yeah,
Okay,
but is scalable? Yeah, my question is relational databases is scalable, horizontally scalable, or they are only vertically scalable? No idea? Yeah. See, what is vertical scalability?
adding resources to the same system.
Correct, correct. Yes. Okay. Someone is asking any question. Rohit? Yeah. Can someone answer, Rohit? What it is looking like? Is it looking like system design, or it's looking like behavioral, or looking like algorithm class, DSA class? Rohit, answer. We are discussing about scalability. What is the scalability? Algorithm, system design, non-functional requirement, or whatever. Yes. Okay. He's feeling like it's a DSA class. Great. Now we are discussing about system design. Today we are discussing system design of payment gateway. Correct. Awesome. Good. So yeah, horizontal scalability. What is horizontal scalability?
Adding more nodes to the
Adding more nodes, right? So can you do that and get a relational database scale? For example, MySQL. MySQL is a relational database. Can you create a cluster of MySQL databases? Right? So that means you need more throughput, you need better performance. So you add more nodes to MySQL, right? Yes, that's possible. MySQL is also cluster-oriented database. It can be horizontally scaled, right? But you should also understand that NoSQL databases are more horizontally scalable. So they are better scalable because with request to SQL databases, they have a limit, and the limit is not the limit of, it is, yeah, you can scale to thousands and hundreds of thousands of users. But when it comes to millions and hundreds of millions of users, databases, relational databases cannot scale. But NoSQL databases are designed for dealing with hundreds of millions of users. They can scale up to, they can also do clustering, and you can add more easily nodes in the NoSQL databases. Right? Because why you reach a limit for SQL databases? Because as you are adding more and more nodes, more replication will be required, and there is a limit, right? Because replication is expensive process. So then you get into scalability issues with NoSQL databases. Great, great. So flexibility, what do you mean by flexibility in NoSQL databases? Anyone?
We can store any type of data.
Yes, yes, yeah. In relational databases, you can't store any type of data.
Oh, we can store, but the data in the form of rows and columns only. So we need to define the structure first, and then need to store.
Yes, yes. Schema needs to be defined. You cannot store data which is not as per the schema. So that is the limitation of relational databases. In NoSQL databases, you can store data which is beyond the schema, right? No need to define, no need to have a predefined schema. Yeah, Harsha, you are right, absolutely right. Very nice comment. As I said, you need replication, or you have also described it in another way, like there is a sync which is required, and sync is nothing but a replication, and it becomes costlier, right? So this way, do NoSQL database do not require sync? They would also need the sync. Why it is not that costlier in NoSQL databases? Harsha, for you, this question, what do you think? Why? See, consistency is important in relational
Yeah,
databases,
relational databases.
but in NoSQL databases, non-relational databases, consistency is not guaranteed. So sync is less expensive there. Replication need not have to be there. Right? There could be some algorithms. We'll discuss that in detail, how they determine if there is data out of sync. You can always rely on some other protocol to determine if from two sources the data is inconsistent, then you can take the latest one, or you can take the one which is more consistent across various clusters, right? So for example, if you see a price as 100 rupees in 3 clusters, and in 2 cluster you see the price is 90, which one would you trust? Right? So you can trust the one where is maybe the most clusters are saying it is 100, so that could be the right value. Awesome. Awesome. So this is about NoSQL databases. Awesome. Great. Now, you understood about payment processing, and we will be discussing further details about design, because now we have to start designing. We have just chosen one component, which is the database. So let's plan the design, right? You would need clients here, right? Definitely UI is required for payment, a Paytm kind of application, or in UPI, you don't have a UI, right? UPI is a backend system. But yes, in the system architecture, you have to give the first layer as a client layer, because definitely some other UI will be required, right? In UPI, what is the UI? Anyone knows? UPI is a government backend system, which is the best in class system amongst all the payment processing system in the world, right? So BMAP you would have heard of, is again a government app, is the app which is from UPI, same institute, NPCL. So you have a mobile front end, and you may have a web front end as well. So this is your client. This is definitely one component available. What could be the other components which could be required here? See, a payment gateway will have a lot of APIs. Yes. So what would be the APIs which we'll be having in a payment gateway?
Validation of a user.
Okay, awesome, nice. What else?
Committing a transaction.
Okay, great. Then so yes, right? We'll talk about the API. Okay, what are the APIs for payment gateway? So we may design some REST APIs for payment gateways. So in the payment gateway, we may have APIs like, what do you do in the in payment gateway, right? You may search for the bank account number, right? So with mobile number. So you may say search bank account and input is mobile number. Correct. So, and it would be string. Mobile number is a string. And then you have return type is again a string, which is a bank account number. Correct. So this is one way. Able to hear me? Clear? Okay, perfect. What other APIs could be there? There could be search bank account, transfer money. Yes. Transfer.
Choosing the bank account.
Yes, using the bank account, definitely. No, in UPI, you don't use the bank account, but yeah, you use the string mobile number, get the bank account, and then yes, finally you use bank account to make the transfer, and maybe you will have, say, the amount which you need to transfer, which could be floating point, right? So basically bank account is nothing but a string. Right. So yes, these are the APIs. There could be many other APIs as well, which is validation. Okay. So when you have a bank account, you have to validate the bank account details, etc. Yes, I agree. So you have given, and there would be many internal APIs as well, which will be around settling the money, right, to the merchant's bank account, giving refund or giving some details about the payment, previous payment. So I may want history, giving a history for all my transaction. That could be other API. So you don't have to go into so many API, give some example. But yes, you should appreciate that this is, there are a lot of APIs, right? There could be API for doing the KYC also, right? So KYC, how you will do? You will give the user ID. You will also give maybe your PAN number, right? And you will give your Aadhaar, and you will get the status of the KYC, probably whether the KYC is successful or not, right? So you may return a Boolean value here, or your KYC ID also you can return. History will give you transactions, right? Maybe array of transactions. So there could be many APIs. What we should appreciate is there are many APIs which will be there. So we may need a load balancer here, and you may need to have various microservices which will be dealing with the APIs, right? So APIs, you would see based on separation of concerns, you will partition them, right? What I would advise is here, how it is done is you have two kinds of services. One is financial services. Other one is non-financial services. So there are two kinds of services. So yeah, transfer money is a financial transaction. Search bank account is non-financial transaction. Get a history is also non-financial transaction. KYC is also non-financial transaction. So separating between financial and non-financial transactions would be an important consideration, because you would need more security in financial transactions, and you may need more availability in financial transaction. If my history is not available, not that big problem. If KYC is not happening, yeah, you would see that many times it happens. You try doing checking for bank account, does not work. Try doing for KYC, maybe does not work. But still, application is available. You can do the financial transaction. Financial transaction is most important, should be working all the time. So you've put more infrastructure in the financial transaction, less infrastructure in non-financial transaction services. So this is one classification how you can do separation of concerns at a higher level. But yes, there are many services, so there may be many financial microservices, and there could be many non-financial microservices also. And then you need load balancing, right? And there will be many clients. UPI app is an app which is used by many clients. Book My Show had only one client. Your Tiny URL also has one client. You have the API, but yes, mostly it's consumed by one client or two client, three client, few clients. Here you have many clients. For UPI system as a payment gateway, it is used by Paytm, GPay, Bheem. So many apps are there, right? MobiKwik, Amazon Pay, hundreds of clients are there. When you, so that means you have it's a payment gateway is not a application. It is a platform. It's a service, very widely used service. When you have this scenario, you generally use API gateway. So just remember this, that API gateway is something we use when we have many clients and we have many APIs, and you need to manage many APIs amongst many clients. Right? So your clients will make a request to API gateway. One simple reason I'll give you. Assume you are a developer. I asked you that please develop a client like PhonePe. Now you will go to UPI, you will see that there are so many services. These will be like maybe tens of services or maybe 100 such APIs are there. And then I say, okay, there are various microservices also. I have financial microservices, which may be dealing with transactions. There could be many, maybe dealing with credit card transactions, dealing with bank accounts, dealing with loans. There could be many financial microservices. Same, there could be many non-financial microservices, which could be dealing with users, dealing with businesses, dealing with KYCs, dealing with history, dealing with taxation, blah, blah, blah. So as a user, you will get completely overwhelmed by, oh, so many microservices are there, and I have to read about so many documentation to implement this app. But what payment gateway does is, and also in the code also, for some you are calling this particular service, which has a different endpoint. For some you are calling some other endpoint. So API gateway takes care that you have a common gateway and it can route the request to the appropriate microservice, right? So this is one advantage of API gateway. API gateway does the routing. It also does the load balancing amongst multiple services, microservices, right? So I would have multiple microservices for financial as well as multiple for non-financial as well. Right, so let me do this. Now, what does these services have to do? Whether it's a financial service or a non-financial service, you have to deal with different banks, right? There would be many banks. Let's say HDFC. Then I'm just putting the top banks. You have to do this. No, there are so many. In real implementation, what UPI has done, they have dealt with so many banks, right? All the banks. Yes. So you have so many banks. But yeah, exact name does not matter, right? So you have many banks is what you should be aware of. But yeah, each of these bank may have a different APIs. So you have to call from UPI system these bank APIs. But if these banks have different APIs, then that's a problem. You have to write so much of code. Why not create another layer, which is an abstraction layer, which is the bank interface, right? With this bank interface, you write the code, you connect with this code here, adapter pattern in place. This is an adapter for all the important APIs. So for example, check balance adapter. Let me put it like this. So this is kind of a bank interface, which is an adapter. So what it does, assume you do the check balance for SBI. It will call the appropriate API for checking the balance in SBI. If you do HDFC, this knows how to get the balance in HDFC as well. So it can communicate with any bank, right? So this is what. Similarly, you may have some APIs for deposit and withdrawal as well, right? And for other use cases as well. So this is your adapters for various transactions, various operations. Same thing, you will have a ... here as well, because there will be many such operations. Again, I don't have to list them all. There will be many, but this is the idea, right? So let's also put some microservices for mandate. Right. So let me just remove this part, and you have add something called mandate. Yes, mandate microservices about mandate transaction, which is some transactions in future. You are authorizing some transactions to be done for future. Definitely, you need strong authentication mechanism also, right? So you need an authentication for, because if unauthorized people are accessing your APIs, this is a security problem. Yes. And whatever you are doing operations, you should store these operations in the database. Right. So this is our database. Let me draw this database. This is the database now. Right. So everything which is we are using, consuming, is getting stored in the database. This is the overall architecture of payment gateway. Yeah. Yeah, your API gateway will also take care of authentication. If the request is authenticated, then only it will forward to the right microservice. Otherwise, it will not. Hmm. right? So there could be many other services which you may also think of. For example, one service which I may think of is fraud detection, right? In case someone asks that, yes, you should have fraud detection also. Someone may ask that, yes, we should have encryption also. What all information which we are sharing, for example, the credit card, the encryption should happen for that service. So yeah, you may have such layer of various third-party services. So this is another layer which I will call as a utility layer in my architecture, high-level system design, right? So this is how you do the system design of API gateway. Okay. Now next thing is we have to verify all the requirements. Is the architecture meeting all the requirements? Right? You say, okay, we should be able to do bank transfers. We should be able to find the bank account details, etc., from the mobile number. So yes, definitely. We have the service for it. So yes, you will have a mobile client which will send a request to maybe check balance, right? So when you do check balance, first thing is the request will get authenticated. Yeah. If it is valid user name password, it will be forwarded. Otherwise, it will be blocked. If it contains any sensitive information, maybe it has some, maybe I'm doing check balance on my something which is sensitive. I'm sending some sensitive information, then it should get encrypted also. If I'm doing some transactions, then it should also pass through the fraud detection also. Fraud detection is, anyone knows what is fraud detection? Tell me, who will tell me what is fraud detection?
Using fake applications,
Yes, yes.
in
Right.
our college, a lot of people fake their payments when they are
Yes.
buying cigarettes and, yeah.
Yes, absolutely, absolutely. So fraud detection is identifying fraudulent transactions. But how is it detected if people are doing fake transactions? Basically, someone may be doing a fraud. You have to detect what is a fraud. Maybe someone is using someone else's bank account number. This is a fraud. If I am using someone else's credit card number, making some booking, then this is a fraud. What I'm doing is a fraud. But how can you detect? Assume I'm using someone's card who is living in US and I'm doing some transaction from India. There could be some signal of fraud. So basically you use some AI techniques here. There are advanced algorithms. There are systems which engage into figuring out the pattern of transaction. If they say that, okay, maybe generally users are doing some transaction in a particular pattern. If they see that there is a different pattern which is coming up, this could be a possibility of fraud. So system should flag as a fraud and should block that transaction. Right? So this is also very important feature. So if yes, everything is fine, then request is forwarded to the required microservices. API gateway will know about where that microservice is. So the developer or mobile client only need to know about the API gateway. This is also decoupling, right? And then once you have here, the transactions will go to bank interface and bank interface will connect to the appropriate bank server to fetch the detail or deposit the money or withdraw the money. This way I have validated most of the use cases can be taken care of with this architecture. All the use cases can be taken care with this architecture. But yes, this is only the 10 or 20% part. Most important part is how do you validate whether our non-functional requirements are satisfied or not? Because that's challenge. That's the biggest challenge. Let's say we have 500 million users. Definitely we have a database. But when I'm making any transactions, when there is a high scale, the database may become bottleneck here, right? So let's talk about what is database here. So in a payment gateway, tell me about the database design. How will you design the database for payment gateway? What will it contain? Who will tell me? What data to store? Yes.
The person mobile number
Okay. Okay. Yeah,
that is
person.
associated.
Yes. But before that, you store the person. You store
Yes.
users. Say, assume you can take an example. If you are familiar with, say, PhonePe, GPay, Google Pay, you just think of what all information it stores. So definitely it stores users, right? User has mobile number. User has your ID, maybe name, email, mobile number. These all information you will store. And definitely username, password, right? So you have password as well, username, password, right? See, mobile number is very important here. Maybe you will use this as an index, right? For faster lookup. What else? Other than this, anything else? What is user having? See, you should also understand every user. I'm also drawing the class diagram. Parallelly, every user, what should have? It should have
Account details, right?
yeah, accounts it will have, but yes, also every user should also do KYC. KYC is important. And a KYC will have, again, user ID, right? It will have PAN, Aadhaar, right? And then KYC has an expiry date. So that's another important data which you need. So a user can have many KYCs. One at a time, but many KYC, one activate KYC at a time, but I may have many expired KYCs also. So the relationship is one to many, right? So this is, and this one is one. Every user will have many KYCs, but yeah, one active KYC at a time. Right. So account details you don't have to store because account details are stored in the bank. Yeah. But if you have a money in a wallet, right? So that you may store here, user ID, and then wallet balance, right? And then maybe when was it updated? Last updated, right? So this could be your values, which could be there in any payment gateway like Paytm. Yeah. So here I'm putting also wallet. A user will only have one wallet in a particular payment gateway. So 1:1 relationship. right? So for Phone Pay or Google Pay, either you are a user or you are a merchant. If you are a merchant, name, email, mobile, you are also user. But for merchant, they need to take care of the bank account details. Right? Because when you will be accepting the payment, say assume you are some vendor and you are expecting some payment, that payment should immediately go to your bank account. So that's why you put bank details as well. Yeah. So I would also take your point also. Now, bank details are required not for users, but for merchants. A merchant may have only one bank account here. Correct? One-to-one relationship, because you need to know which bank account to transfer the money. So I can limit this to one-to-one. I can put one-to-many also, but many of the payment gateway, they say, okay, you should have only one active account and all the money will be transferred to that account only. Like, for example, you may have many bank accounts, but when the salary is getting credited with your employer, you will have only one account registered in which you will get the salary. In the same way, in the payment gateway, if you are merchant, you will get your one account registered. This is your account where you will get all your payouts, right? You will also need to know, yeah, what else? Transactions, what you will store. This is the most important part. Transaction is what? Is having an ID, you know, the sender, receiver, amount, maybe date, time. This what is your transaction details.
Status.
Yes, status you can have. Status could be there, right? Yeah, I can put status. See here, identify entities is very important because there could be many fields. But yes, you can't design every field in 1 hour. But yes, you should share that you have most of the fields which are described. Payment method, right? So this is also very important because I may want to pay with many methods, right? So what exactly is the payment method available? There could be a list of payment methods. This is for user. So when user is adding money to a wallet, there could be a list of payment methods through which a wallet could be paid, right? So payment methods. I will put another entity here. And this is, yeah, basically this is many payment methods through which the wallet could be paid. So these are various tables which you will need for the database in the Paytm. But yes, see, there are so many users, millions of users, this part. So this is very critical part. Yes, users, there are many users. So any query which is dealing with users may become slow. So how can you speed it up? Right. One is use the indexing. I index it with mobile number because people are likely to search users with the mobile number. That is fine. I can get some optimization, but still it may not be fast enough. So what is the solution? How can I fasten up the database? Even if it is NoSQL database, these will not be tables, these will be documents, right? If assume I use MongoDB, then I will be storing this as a JSON record. And then these are the documents which I have in the database, and each of the document is a record in my database. How can I speed up a database? Anyone? Query optimization, indexing, having views, all these we studied. These are there, but I'm talking about externally. How can you speed up? We did that in tiny URL also, because in tiny URL also, we required a lot of speed. Yeah, because your lookup should be fast. We need always in all the databases, in all the system design, never forget that component. Always add that component. What is that component?
Caching.
Cache. Yes, you should always have a cache for the database. So let's add the cache here. I added the cache. Now I can say, yeah, my database is now more performing. It will have low latency because rather than querying the database, I'll be querying the cache, and cache is faster than the database. Now, other question, why cache is faster than the database? Can anyone answer? In the interview, I ask you, why do you think cache is faster than database? Generally, we use in-memory cache, right? In-memory cache means cache is in the RAM. So it's faster than data in the database because data is in the hard disk, right? So that's why cache is faster. Also, cache contains lesser data. So the searches will be faster because it is not storing everything. It is storing the most frequently used data. So don't cache everything, because if you cache everything, then your cache will become slow. Keep the cache slow is lower because this will be less expensive as well. And you will get good performance if you are putting good eviction policy. Good caching strategy is important. So that is one thing. Yeah, load balancing we are doing here. So these services, we have created multiple instances of the services. API gateway is doing load balancing. So there's no problem in scalability performance here. No problem in scaling and performance of microservices. No problem here as well. So one problem solved. Yeah. another way of improving the performance of the database. See, cache can increase which performance? Performance of read or performance of writes? See, this is very important point, right? We solved the problem only half.
Read performance.
Cache can only increase the performance of read. Now you will ask, okay, how can we improve the performance of writes? So tell me.
Using a master slave architecture.
Right? Yeah, that is good answer. You can use master slave architecture, or basically you need multiple replicas also. Definitely, there is another problem with the cache also, that availability could also be a problem. So you need replicas. Basically, you need a lot of databases here. Replicas. So let me draw here more replicas. Right, so now you understand this is replicas, but yeah, let me just keep these boxes so that you understand, and these are replicas. So this. Yes. So this will prevent, in case one database crashes, you have other instances where you can replica, because reliability, availability is also important, right? So if you have multiple replicas, then this problem is also solved. So the architecture is now reliable and available also. This way you will be involved in ensuring there is high availability, right? And yes, definitely here load balancing will also ensure high availability, because here also you have a lot of clusters, and now you have database also a lot of clusters. Definitely here in bank interfaces, you will have clusters. In the HDFC SBI, they will take care of reliability, availability here. And this also, you will need high availability. Yes. Multi-master, having multiple masters will improve the write operation performance. Correct? So Ramesh, you are correct. Master slave by default do not improve the write performance. But if you have multiple masters, then you get high performance. So here what I mean is multiple masters, right? Replicas of databases.
Oh, how it will improve? Because
Multiple masters.
yeah.
So you can write to, you can have more connections, right? Basically. So what does it mean by having more masters? That means you have more database instances. So if suppose you have 2000 requests and your database can only accept 1000, then having two masters will be able to deal with all the load, because now you can write to the two masters, right?
Okay.
Which will sync up automatically. So this way it will improve the performance of writes, right? Basically,
Yeah.
how the load balancer, you will get the load balancing for write operations with multi-master architecture. not a single master slave architecture. Master slave will increase reliability. Master slave will increase performance of the read because you can read from all the slaves. But if you read from multiple masters, then you improve the write. If you can write to multiple masters, you can improve the write performance. So multi-master configuration is also possible. So now this, with this architecture, with here basically load balancing in place, you have all the non-functional requirements also satisfied, right? So if you give this kind of architecture in a system design interview, see, we gave the database design, we gave the API design, we gave the design of schema also, relationships between various instances, entities. We also gave here see, this is the most important part. Never miss this calculation part, back of the envelope exercise. This is very important. And yes, the rest functional requirement, non-functional requirement, we have done it so many times for so many applications. You will never miss out, I am pretty sure. But yes, do ensure that back of envelope calculation you do, and your decisions are based on your calculations, right? There is still a problem here, a scalability problem. I'll tell you why. There is also performance problem. Communication between this servers and database, no problem. You have cache, replicas, so database performance, not a problem. Communication between API, gateway, client, and microservices, not a problem, because here you can do multiple clusters, multiple server instances, load balancing, etc. So here, not a problem. But there is a problem. What if these services have to communicate with each other? For doing various transactions, these services also have to communicate with each other. There you can get more load. There is no load balancing here. Yes, and one service may be talking to multiple other services. There is a problem. Understand? Correct? How to solve this? How can we make this communication also more scalable? Right? If you give this answer, this is 80% correct, but not 100% correct. Interviewer may ask you that yes, this is the layer where the performance problem could happen. See, this is, I'm doing step-by-step architecture. I'm also analyzing that architecture, and I'm sharing this same approach you can apply while analyzing any other architecture. So basically you see all the interconnections. Are they satisfying all the non-functional requirements? Because we required everything. We required performance, we required low latency, caching can help here. Many replicas can help here. Availability, fault tolerance, everything. These things can be achieved, right? With caching, with multiple replicas, disaster recovery and all that can be taken care with the help of multiple database replicas, because if one replica fails, you have a copy of the data in other replicas. So here it is fault tolerant, available. But then we also have to think about communication between various microservices, because when I'm transferring, I am also searching for the bank account by mobile number. And that means various microservices will be talking to each other. So how can we increase? Any clue? This approach we have not yet discussed, but I want to introduce you here. So there are many kind of interconnections. Many services are talking to each other. So what you can have is, you can add another component here. This component is called message queue. So rather than communicating directly with each other services, message queue, you communicate to the message queue. All other services will read from the message queue. So in case there are, so message queue like Kafka will ensure the messages can be consumed very fast by the services. And when you have multiple pool of processors, they can distribute the messages to the other services very efficiently in very fast manner. And if some operation is long operation, message is always there, persistent in the queue, so you don't lose this. Message queue acts as a buffer. And even if all the financial, non-financial services are down, this makes the application fault tolerant as well, because you will not lose the message, right? Assume I gave the example here. I told him there could be a service which can be available in the last class. Remember, there could be a service which can be available but non-reliable, right? May not be reliable. So I gave an example that I'm sending a payment. Paytm is always up, but every time I'm sending a payment, it is getting rejected because it says, okay, the server is down. So since Paytm is up, my application has high availability, but my transaction is not successful, so it's not reliable. And I'm also losing all the data which I'm entering because the transaction does not succeed. So you have to again enter the credit card detail, etc., etc. But what if I use a message queue? Because my message is also getting lost. In a message queue, your details of the call is also saved. You can retry it, right? And this way you don't lose your messages as well. It becomes fault tolerant. As soon as this non-financial service will be up again, it can read the message again and reprocess it. Even if it crashes, message could be processed again. Right? So this is about message. I also discussed this architecture. I collected inputs from architect of UPI. I will share the link also. I recorded a meeting because this was something I could personally validate the architecture also, right? Because UPI, I knew the architect of UPI very well. So I advised him, can you please share me and explain the UPI architecture? So he did that to me. I will share that meeting reading with you all, because I also invited that time. That I did it around, I think, a year back, right? More than 6 months back. So now let me give you some more insights here. So with message queue, your communication between all the services is also taken care. So this is good, right? But yes, one problem can still arise. If you have many replicas, and many writes. There will be many calls which will be coming to the database, and a lot of replication will be happening. You will be continuously replicating that data. And cache may also become, yeah, you would be writing also a lot of time to cache. This will be a problem if there is excessive writes. Right, so that is one more problem which we should solve. Right, so actually, if I give you the exact architecture of UPI, now you know the message queue. So here, why not just leverage the message queue for this communication? We can also leverage this message queue to faster read and write. Right? How? I will tell you. This is how it is done in UPI. So in UPI, you have here clients. Next, what you have is you have load balancers. Right? With the active passive configuration. Then you have microservices. Then you have here in-memory cache. Yes. And what they do is everything happens from in-memory database. They don't use the database at all. Everything they take care from Redis or in-memory cache. Yeah. So here you have all kinds of microservices. Financial, non-financial, mandate, they have a message queue here. Message queue is used for communicating across various microservices, right? And this message queue is also used to communicate with external services, which is like various DB processors. For example, they will have settlement systems. They'll have reporting systems. Yeah. For analytics, you need a lot of reporting systems as well, right? So these systems will also consume the data from message queue, and then they will write to a persistent storage here. Right, based on some events. Right, based on the messages and events, they will write to persistent storage. And this database is Cassandra here. This database is Redis. Message queue here is Kafka. And yes, these are various services. These are Java-based microservices or DB processor. Microservices may also use different technologies. Some microservices may be Python, some microservices may be JavaScript, Some microservices may be any other programming language, C#. So could be dependent on various implementation. So this is how it is achieved basically. So here the flow is client makes a call. There is a load balancer or API gateway in the active passive configuration, which forwards the call to the microservices. When microservices are calling, they always talk to a in-memory cache. This in-memory cache is all the recent transactions. Basically, you are highly likely to refer to the data which is there in recent time, maybe 24 hours or a week. You are less likely to refer data which is older data. In payment gateway, that is the case always. Mostly when you do the transactions, you deal with the bank accounts which are recently used. So they use the most recently used kind of cache. But yes, everything which is there is in memory cache. All the bank accounts are there. So this is, you should not call it cache, because since it's containing all the data, I will call it in memory database. They don't have a concept of cache. They have the entire cache is the database for speed. And whenever there are various operations being done, all the messages, transactions are also getting updated into the appropriate messages. Messages will be posted on topics in message queue. I'll cover message queue in depth in the next session. But yes, in the next session, I will also cover microservices and message queues. Because to understand this, you need that understanding also thoroughly, because I understand. But I believe that yes, you would have understood until here very well, right? But when I did this, here it is little tricky for you, because we have some concept of message queue and in-memory database, which is coming. So we will cover in the next classes, message queue, microservices. Microservices, you know, as such, you don't need to know many things in detail, but yes, I'll cover some microservices patterns also, so that you will understand that what is microservices and how it can help you to design a big application as a microservice rather than monolith. And when to use monolith also, I'll cover. And then finally, we'll cover message queues, how and what exactly can message queue do. But yes, here what you should understand is every transaction getting stored, all the data is stored in the in-memory database. This is very fast because no RAM is, no hard disk is used. Everything is in RAM. But the problem with in-memory database is if that RAM crashes, if the machine crashes, you don't have any way to recover it. So how do they solve this problem of recovery of data? They use multiple clusters of in-memory database. So this is one approach. So if one in-memory database crashes, they maintain multiple copies of in-memory database. Other thing is, they are also storing it to the persistent. This is a normal database, which is Cassandra database. And this they are not doing, they are doing based on DB processors, which are scheduled at daily, weekly time frame. And these DB processors, what they do, whatever messages are there in the queue, this they will take and they will sync basically the data from the database to the Cassandra database. right? So from in-memory database to Cassandra database. Cassandra is a hard disk based database. Again, you will use here multiple clusters so that you get very good performance. And this database is used for various purposes, which is settlement. If monthly settlement has to be made to the to a vendors, then you need a lot of transactions, right? So if suppose you are paying something to some store, and in that store, hundreds of customers are buying. So that payment gateway will transfer the money either daily, weekly, or monthly. So then it will process the data from the Cassandra. And this way you will be able to see this. This is high throughput database and good performance you will get for reporting, settlement systems, etc. And here you will get good performance in memory database for all the microservices because they are referring from data to here. What also they take care of is they use sticky sessions. So that means the load balancing strategy, what they use is, if I am using server 1 for one of my transaction, right? So server knows the previous state of the transaction. So there is a cache in the servers also. So with this sticky session, whenever I'm using, if my request is going to server 1, so sticky session means if I make another transaction, again my request will come to server 1 only. So this server will kind of be dedicated for serving my request. The advantage is it will know my history. So if I have done my transaction once, again, if I do the transaction, that will be faster. So this is another optimization they use to improve the performance. And they do this because here performance is super critical for this application. Right? So let me now highlight. See, we have covered the design. Now, what thing you have to do is you have to learn about in-memory database. Right. So here in this case, Redis is our example. The use of this is faster read and writes. Yes. Because hard disk will always be slow. Yes, sticky round robin is what, right? Round robin, because sticky session is same as sticky round robin. Yes, so now let's come to advantage. Is highly scalable, right? The in-memory databases, Redis is highly scalable because it's designed for working in multi-cluster environments. See, there is multiple replicas of in-memory databases. So at a time only one will crash, others will be running. So I don't lose the data. And I'm writing the data to the Cassandra also. Even in case all the in-memory databases crashes, I still have the data in the Cassandra. So I can populate from Cassandra. This is my hard disk storage. So here Arun had this question that what will happen if all my in-memory databases crashes at the same time. If that happens, you still have a data in the Cassandra. So you'll not lose all the business because of that. Because yes, one risk is, if assume flood came, all my data centers are there in one particular region, say Delhi. Some flood came and all my memory databases are lost. I run out of business, right? If Paytm is just using one data store, then that is a problem. It will again have to start acquiring the customers from scratch because all the customer data is lost. But no, that will not happen. They'll maintain it in multiple regions and multiple clusters. And even if all the cluster fails, you have still Cassandra, Redis. In addition to Redis, you have Cassandra where data is available. You can copy from there. So, yeah, but if you restart a machine, in-memory database is gone. All the data in the in-memory database is gone. You should need a way to repopulate it. Basically, you have to repopulate it. So you may have to keep a backup. And then once the server is back again, you initialize the database again with the help of backup. So in-memory databases has some disadvantage. One disadvantage is cannot store very large amount of data. Right, so these are the advantages. And these are the disadvantages. Cannot store because it's expensive. So you can't have terabytes, multiple hundreds of petabytes of information. Terabytes of memory is also available now. RAM is available, but petabytes of RAM is not available. And then the other drawback is power failure or system crash can lead to data loss. So this we counter by having replica and as well as a secondary storage, which is Cassandra. In-memory database, sometimes they are also referred as, in short, IMDB, in-memory database, because they store entire data in RAM. They do not store the data on hard disk. And that's why they are fast, because the speed of in-memory database is more than thousands of times than the disk-based databases. And using message queue also makes our database event-driven database. Our application event-driven application, right? So this is known as event-driven architecture, is also known as EDA, right? So basically what actually we are focusing here in event-driven architecture is about events. So transaction payment, KYC, right? User account registration, etc. All these are events. And whenever there is an event happening, we have entities, and with events, a state of entities changes, right? And this is communicated through message. Basically, messages and events are same. And whenever there is an event occur, some processor can take some processing. It can consume the message and can do the processing. And one such processing which we are doing is, we are storing, in case of any event, the data into database, which is Cassandra database, also from in-memory database. This way we are achieving reliability, high availability, and also making our application high performing. So sticky session, in-memory database, everything is ensuring low latency. So next, let's discuss the advantages of message queues. Message queues. Advantage is scalability, right? It decouples loose coupling. This is another advantage, right? Because earlier you need to know that, yes, financial services needs to talk to non-financial services, how the communication should have. There should be someone who is orchestrating. One service should be controlling the call to other service. That is called orchestrating, right? Now here, we don't have that orchestration. We are just sharing the messages, and asynchronously they are doing communication, right? So other advantages, asynchronous communication. Can anyone tell what is synchronous communication? What is asynchronous communication?
In synchronous communication, they need to wait for the result.
Yes, absolutely, right? So asynchronous communication is very helpful when you don't have to wait for the result, or if you need some long running process. Asynchronous communication is very beneficial. You also get reliability and fault tolerance. I explained this in detail, that message will not be lost even if a processor crashes. Yes, you don't have to retype again the details because message is stored in the queue. Queue is basically a database you can think of, and messages are various fields and objects or tables. And
I
then,
have a question here.
yes,
So there should be a mechanism of acknowledgement, right? So as to confirm that the message is consumed or something.
yes, yes. Right, so reliability, awesome. This is another point which you shared. With the help of acknowledgement, you can ensure that the messages are reliable. The application is reliable. Because if you don't see the acknowledgement, you may resend the message again. Right? So that can also be guaranteed. There are various configurations which can be done in message queues. So acknowledgements are another mechanism of ensuring that your message is delivered at least once, right? So reliability fault tolerance, and performance. High performance. These are the benefits of message queue you have to tell. So my architecture is having all these positives. Right. So what actually, let me give an example how it can work. So assume I started a payment. Maybe I made a payment to some account. Maybe say I bought something from Amazon and I'm using UPI payment gateway as my, see, this is the architecture of UPI, right? So I'm using UPI as a payment gateway. I entered my UPA or mobile number to deduct the money. So definitely from the client, there will be a sticky load balancing, which will be happening, and I will be redirected to one financial server. This server will already have my bank account detail because it has requested this earlier. And since my session is sticky, it knows me, and knows my bank account detail, and it also knows Amazon account details. Because of a sticky session, if I have done previous transactions with Amazon, it will have this in its cache. So it does not have to look up again. If I am doing some transaction to a new vendor first time, then it has to look up for that. But yes, the next times it will have this in its cache. So this will be improving the performance. Then it will know the wallet balance, or it will very quickly do the transaction and store all the required details in the in-memory database. So when it will do the transaction, basically it cannot do transactions directly into the HDFC, and assume my account is there in HDFC Bank. So it has to withdraw money from HDFC, and it has to maybe deposit money to some other bank account. So that may take time. So here it will send a message to the message queue, payment initiated. And this becomes a asynchronous processing. So there is a message with this name that your payment has been initiated for Amazon. And then in the background, fraud detection, encryption, everything will happen. Authentication, etc. Yeah, that will also happen, because even before the transaction is initiated, they will authenticate. And yes, if I have right authorization, I may authorize by Face ID, biometric, or by PIN, or by some password, etc. And then the authentication happens. And once the payment is processed by HDFC Bank servers may not be that fast, but yes, once they have processed this, it will send another message saying that payment confirmed. And this will be picked up by the service again. So it's now not waiting. It is started serving other customers also, because it just made a request and the message was created, payment initiated, and now it's not waiting. It will re-trigger itself when the event payment processed or payment confirmed will be there in the message queue again. So once it sees payment confirmed event, it will check, yes, this payment is confirmed. Which payment? It will see the payment ID. It will say, yes, this transaction was for this and this person done this much time before. I will confirm it, and it will close this transaction. So this is how things will happen, and it will happen very reliably, high performing way, and in a very scalable manner also. So this will ensure all my non-functional requirements are also satisfied.
I have one more question here. Since we
Yes.
are communicating, I mean, sending a message through message queue,
Yes.
in the scenario of failure, how will the upstream flow happen? I mean, from bank to client.
Yes. Correct. Yeah. Say there is, yes, let's talk about that. Yes. So basically, there are two services, right? One is the payee, right? Other one is a receiver. Right. So when you initiate the payment, yeah, pay will. So this is basically the payment service will be there. Will post this message, right? So pay will call the payment service, and payment service will create a message saying payment initiated, right? Now, I also say that there is a service which is, say, withdraw service. Let's call this is a withdraw service. Withdraw service will see this message. It will call the other service, which is the adapter service, right? Basically, let's forget about that also. Adapter service, yeah, because yeah, let's call this is adapter service, and then through adapter service it will call HDFC. Assume the withdrawal has to happen from HDFC bank, right? Now withdraw service can deal with any kind of banks, SBI also, because it only knows how to work with adapter. Adapter service is capable of sending this message to any of the bank, whichever is required. But yes, in this case, let's say this is the bank where the payment has to happen, HDFC. Yes. If this fails, right? So assume this, and due to any reason, this transaction failed. Yes, so transaction is failed. Yes. So the failure communication, adapter service could not complete the transaction. It will notify the withdrawal service. Withdrawal service will post a message saying that payment failed. You have a transaction ID associated with every message. So transaction ID 1. You will also have amount, say this is 100. Payee, right? XYZ, receiver, right? Whatever ABC. You will have a lot of details in this, right? And in this also, you will see the same details. So you can match that, yes, this transaction ID is failed. So this is communicated to the payment service, and finally it will get communicated to payee as well as to the receiver also, that yes, the payment has failed. Right? So do not ship the item because payment has failed. Yeah, this information will go. Yeah, basically, receiver will either know the payment is confirmed, so it will process and ship the item or whatever it has to do with that payment. If it failed, then it will show the error message to the payee. This is the entire flow for failure scenario. Success scenario is also same. Instead of payment failed, you will get a payment success message, right?
Yeah.
Or maybe you can have a status field in that message where failed or status. And based on that, you will either confirm or cancel the transaction.
Tarun,
Yes.
in the above diagram, is there any link between in message and the message queue? In database and message queue, one check.
No, there is no direct link. Is through the service, right?
Okay.
Yeah, so database is, see, database does not process anything. It's just the data. It stores the data. That's the only functionality of database. So you never consume messages in the database because database do not have to process anything. It just has to store things. So services will only store in the database or read, basically read from the database, read and write from the database. Database can only do two things, or you can say it cannot do anything. It can be only read or it could be written, right? It's a passive person. So it cannot react. You can store and you can retrieve from it. Database cannot do anything. Services are active participants. They can read and write or perform any operation, process the data, whatever. So they will be reading from the data, from the message queue, and based on whether the payment is success, they will write this transaction, or if it is failed, then they will delete that transaction or they will update accordingly based on the messages which you are receiving. So let's discuss about one more topic today, which is caching. Because caching is again it has subtopics. Now you know advantage of caching. Caching is a technique to improve the performance by storing frequently access data in something called cache. Cache is nothing but cache is a temporary storage. Right? And it is temporary storage and definitely faster storage. Because it should be faster than the original storage. Otherwise, no need to cache, right? If your cache is slower than the original database, then this is degrading the performance. It has to be faster than the original database. Then only it will be improving the performance. So, see, caching can be done anywhere. Caching can be done in the client side. That is called client caching. right? If you are using mobile, in your mobile, lot of cache will be there. So that is client caching. In browser, there is a cache, browser cache. You would be hearing it a lot. Caching can be done in the server side. Yeah, this I mentioned. Server side caching. Right. So here you will do caching in the client side also. In the Paytm app, lot of caching you will do. Google Pay also you will do lot of caching. Yes, because if I show you my Google Pay screen, you will see all my contacts, previous contacts whom I have paid. And if I have to repay any one of it, it will be fast because it will be from cache. And caches could be distributed cache. So this is a distributed cache. Right? See. So this is a classic architectural case study because it demonstrates all kinds of cache. Distributed cache is something which is for multiple servers. It could be utilized by any server. So this is distributed cache. So distributed cache, server cache, and client-side cache. These are three different kinds of caching. Right, so right, so these are the three different kinds of caching you should remember. Right? What can cache do? What are the advantages of cache?
Retrieves the data faster.
Yes, so main is performance, improved performance. Second is reduces load on servers. Right, because servers have to do less database queries or less server means reduce load on database, basically, right? But yes, you can say servers also because we are talking about caching at the client side also, right? So with client caching, we are using as a general term. So you can use say database reduces load on database or reduces load on servers. And when it reduces load, it improves scalability, right? So this is the advantage of cache. Now, next thing is caching strategies. There are different kinds of caching strategies. I'm talking even higher level, right? We talked about LRU, least recently used. Basically, this is what you can say time-based caching, right? Because you cache data based on the recency, the time frame in which the data was accessed, right? There could be another kind of caching, which could be event-based caching, right? Event-based caching could be whenever there is an update in the data, you have to update the cache. Otherwise, the data will be stale data, which you will be reading. So event, what are events here? We are talking about, could be about data update or expiration. Yeah. Because you may have a expiry time. So in the browser, most of the cache which we use, they have a TTL, time to live. There's a field called time to live. For all the cache objects, there is a field called TTL. TTL means time to live. So it could be 1 minute, 1 hour, or 1 day. If it is 1 hour, that means after 1 hour, the data will be removed from the cache automatically. So that is event-based caching. Right? Based on a specific event. It could be data update, or it could be any trigger. It could be any event. But yeah, these are some examples. There is also something called lazy loading. Lazy loading is data is loaded only when it is requested. Right? So loaded only after when it is requested. Right? So, because either you can do prefetch of data, or either you can do lazy loading of data. If you do lazy loading of data, then you improve the memory usage. Yeah, reduce memory. If you prefetch the data, then you get performance, but your efficiency of cache is not there. So these are some of the terms you should know. You should use it in system design interviews as some of the technical terms, because interviewer will understand it. But yes, you should throw these terms, these jargons, so that to effectively communicate your design. Clear? So we also discussed about load balancing strategies earlier. So load balancing and also have many strategies. We already have discussed this, but yeah, let me list down and ask you, you answer what is this. Right, so these are various load balancing strategies.
Least responsive.
Pardon?
Least responsive.
Yeah, least connection, least responsive. Yeah.
Okay.
That is an also least connection. Yeah, there could be many. Yeah. Least response time. Right, you can say that. Also is another cell. Correct. Absolutely right. I have added that. Added your point also. Round robin means you do on round robin basis, one at a time. Right? First time server 1, next time server 2, server 3, come back to server 1, server 2, server 3. Right? So here you are assuming all servers are equally capable. But what if your server 2 is double powerful? Then you should give that server more weight, more weightage, right? So server 1, server 2, again server 2, then server 3. This is weighted round robin. least responses time. Yeah, maybe some server is responding fast because the request may be of different complexities. First request is very demanding. Then better use least connection or least response time based algorithms to load balance, because connection means how many active connections a server is having. If it's still doing something, then better avoid it. Send the request to servers who are doing less jobs or who are responding fast, right? Sometimes again, number of jobs may not be measure of how fast a server can react, because some jobs are very simple, some jobs may be complicated. So better is you measure the response time of each of the server, ping each of the server and see the response time. Whichever is responding fast, there you share the connection, or they can share the request, send the request. IP hashing is also, sometimes it could be used for geolocating the nearest server. So one approach could be send the request to the nearest server. With IP address, you can figure out the location of a server and you can figure out the nearness of the server to the requester. And you can do that. Or you can use any IP hashing based algorithm. Any kind of hashing you can do on IP address of the requester. This will ensure you can distribute the request evenly. IP hashing can help you out in making the sessions sticky also. Because if I'm sending the request from the same IP address and you are generating the same hash, yeah, because you will be, so you will make the session sticky, right? So basically, this is nothing, it's the same thing, right? IP hashing is sticky sessions, because same IP address, when it's requesting again, it will be allocating the same servers. So yeah, these all concepts we covered, and sticky session we already covered. That is, so you ensure that all the subsequent requests are also served by the same server which processed the initial requests. Right. So I have explained this diagram. I will also be sharing a slide, a presentation, because here this is again based on a lot of research and a lot of collections. So this is all about the high level design of a payment gateway. And also we discussed various concepts, which are load balancing, API gateways. We covered about sticky sessions. We covered about database design, replication, caching strategies, message queues, event-driven architecture, in-memory databases, right? So in the next session, we will cover message queues in depth, and also we will cover microservices in depth. And then in the later session, which could be so in Saturday's session, we will cover message queue and microservices. Then in Tuesday's session, or maybe Tuesday session, we will cover about different NoSQL databases and sharding as well, right? Sharding we covered already, but yes, we can discuss again in depth about sharding. And then we can discuss on message queue anyway discussed. We can discuss on big data processing, data warehousing, and we can do case study of Instagram. So that could be planned for next week, right? Awesome. Great. Good. So if no further questions, if you don't have any other questions, we can close this session, or if you have question, I can take up these questions. Yeah, I'll share in the reference. I'll share about the talk I was talking about with the architect of UPI. So whoever is interested, they can go, but I have covered mostly all the content from that talk. But yes, if you want to listen that conversation, you can also listen. It feels great if you are hearing directly from someone who has architected UPI, the architecture of UPI. But yes, that is not that important. Important in the system design interview is that you should be able to come up with your approach, and you should be able to explain the decisions which you are making and ensure that all the requirement is satisfied with the architecture. Great. Have a nice evening. See you in the next session.
Thanks, sir.
Thank you.